Hi, in this video we will talk about graphs and how to use them to perform segmentation. Segmentation is about finding pixels that share some features. But in the feature space, points that are far apart are usually not related. So calculating the distance between all points might not be necessary. One alternative is to use graphs. Let's start by the definition. The simplest way to define a graph is as a set of vertices B that in this case could be the points in the feature space that are connected in some way by edges E. So we can write this down in this way. There are several properties of a graph. For example, the graph can be weighted. This means that each edge has a different weight that can represent the strength of the connection between two vertices. A graph can also be directed when we know some relationship between the vertices, or indirected when there is no distinction. We can talk about the degree of a vertex to express the number of edges that connects that particular vertex, and many more like path, loops, but for the next algorithm we only need a weighted graph. If you have here about spectral clustering, well, we're going to do something similar. But let's say that each point in our feature space is a vertex in a graph. Then we're going to make this graph a weighted graph by calculating the distance between points. But not between all the points, just those that are close to each other. The choice of the distance metrics depends on the problem. Euclidean, Mahalanobich, L2, you choose. Now we have a weighted graph that represents some relationship in our points. The next step is to calculate the affinity matrix. The affinity can be calculated also in different ways, but for the example, let's use this formula. You can see it in this way. We are trying to find out which vertex are friends to each other, based on how similar they are. So in this case, the smaller the distance, the larger the affinity. And using this metric, we will start to cut edges between vertices that are not similar. Ideally, we want that all vertices within a cluster have high affinity, and the affinity between vertices on different clusters is low. So we need to define a criterion to decide which edges to cut out. If we just select a threshold, we will end up with many small clusters. The solution is the normalized cut algorithm. Imagine that we have this graph, and we identify that all these edges are weak. So we could remove them and segment the graph into two clusters. Let's call this side A and this other B. But before doing so, we need to calculate the cost of this cut. This will be given by the sum of the weights of all the edges that will be cut. We also need to calculate the association of each cut. This means that if we want to cut A, we need to sum all the weights that are connected to A in any way. Then the idea is to minimize the cost of the normalized cut during the segmentation. So for each pair of subgraph A and B, the cost of the cut is the sum of dividing the cost of one cut over its association. This approach favors the cut of larger clusters to prevent fragmentation into small graphs. For example, if we have this graph and it turns out that all these edges are weak, by using only the cost of the cut, also called the mean cut algorithm, we will remove the single edge because the cost of cutting this one is smaller compared to the cut of the group. However, a single point does not seem to be a good result for the segmentation. The normalized cut weights the association, and in this case we will cut the group instead of the single edge, resulting in a better segmentation. As you can imagine, this approach has a disadvantage. It is extremely costly computational. In fact, like other graph problems, is NP-complete. So there's no solution in polynomial time. However, there are good approximations, such as the spectral clustering that uses fast eigenvector-based solutions. Okay, in this video, we talk about graphs and how to use them to perform segmentation using the normalized cut method. See you next week.